Here is an electric field problem where we're going to have something move, and we're going to be looking for velocities. So this is going to connect back to kinematics. Forgot to write the distance here is 6 centimeters. This problem says an electric field is 5,000 newtons per coulomb down. A proton is released from the positive plate, and we want to find the velocity when it hits the negative plate. E field's 5,000 down from positive to negative. So my proton is going to be released from here and then collide into this plate, and I want to know the velocity when it does so. Though I drew this vertically, I'm not going to worry about vertical forces because the magnitude of the electrical force supplied by this is going to be far larger than mg, to where mg is basically irrelevant. Okay. Proton. Facts you need to know about a proton are also on your sheet. We're going to need the mass of a proton, which is 1.67 times 10 to the negative 27th kilograms. And the charge of a proton, which is the same as the charge of an electron, except it's positive, is that. All right, I want to know the force on this proton. The force on the proton is caused by the electric field, so F will equal EQ. 5,000 times 1.6 times 10 to the negative 19th. 5,000 times 1.6 times 10 to the negative 19th gives me a force of 8 times 10 to the negative 16th newtons. This is the force that's going to be used to accelerate the proton. I'm going to need to know the acceleration if I want to find V final. So I'm now going to do F equals ma to find the acceleration. My force is 8 times 10 to the negative 16th. That'll equal the mass of the proton times its acceleration. Giving me a really high acceleration, and that's pretty typical for these types of problems. I get 4.8 times 10 to the 11th meters per second squared. Electric fields are used to launch subatomic particles at really, really, really high velocities. Now that I know the acceleration, I'm ready to do the kinematics to find the velocity when it hits the plate. It's starting from a velocity of 0. I'm looking for V final. I know the acceleration, and I know the displacement is 6 centimeters. But remember, displacement needs to be converted to meters, giving me 0.06 meters. I now am going to use the kinematic equation V squared, V final squared equals V initial squared plus 2AD. V final squared equals 0 squared plus 2. Plugging in this acceleration there. And I get V final to be 2.4 times 10 to the 5th meters per second. Do not be surprised when you get really high velocities, but you want to make sure that it's slower than the speed of light, which is 3 times 10 to the 8th. If you get a particle going 3 times faster than that, something's wrong with the problem.